Okay, so this is going to be our second video for day one of Unit 4, second of three. And in this one, I'm basically just going to answer this EQ3 right here in front of us really quick. So, why can we? So, I'm going to hand you out some formula charts because I'm tired of you guys trying to be responsible for them. Um, but we're going to answer the question, you know, why is it true to say that the area of a rectangle, which we know is base times height from the example we did back here. Why is the area of a rectangle going to be the exact same thing as the area of a parallelogram, right? And it turns out there's two ways to look at it. We're going to look at it mathematically, um, but also just logically. Okay, it turns out logically a rectangle is a parallelogram because it has two pairs of parallel sides, two pairs of opposite parallel sides, right? So this left side is parallel to its opposite, and the top is parallel to its opposite. Hence, it's a parallelogram. So they're the same thing. That's why the formulas will work on either one. Okay. So we already know from the previous video, previous example, the area of this rectangle here was equal to 192, not yards, square inches. Okay. And we're going to see when we have a parallelogram that has the exact same uh, height and base, right? It's going to have this same exact area. Okay. And the way we would do that, we're going to treat this parallelogram like it's a composite figure. We're going to break it into three shapes now, three different polygons. So we've got a triangle, we've got another triangle, and then we've got a rectangle sitting in here. Okay. So we know, or hopefully we know, uh, the area of a triangle is simply equal to one half of base times height, or base times height divided by 2. We know that already, right? The area of a triangle is equal to the area of half of a parallelogram. Okay, so we need to find the area of these triangles, add them together, and then we're going to add it to the area of this rectangle, and we should get 192 inches squared. Okay, so first, we need to know something about the triangles, right? So if I draw one of them separate, they're both identical. If I draw one of them separate, well, I know at least that the height of each triangle is going to be equal to 12 inches. Okay. The problem is, all I know is this angle is pi over 3, and I don't know the base, right? Kind of need that for the formula, don't I? So I could just do basic trig here. Okay, and when I do basic trig, I am going to end up with the base is equal to 4 times the square root of 3. Okay, which is about, don't remember what that is, 6.93. Okay, so from here to here is about 6.93 inches. Okay, and same thing from here to here. Okay, so now that we've got that, we can go ahead and plug into this. Okay, or this. This is kind of a little bit more convenient for our purposes, right? And we have two of them, right? There's one here, there's one here. So I'm going to say 2 times the area of base times height, right? So base times height, all divided by 2. And if we know anything from basic algebra, what's going to happen with this multiplication by 2 and this division by 2? Well, they're going to cancel. And that leaves me with 4 square root of 3 times 12, which of course is 48 square root of 3. Okay, simple. Okay, so now we need the area of this rectangle here so that we can add it to the area of the two triangles. Okay, so, and I need to use my units, so that's square inches equals the area of the two triangles. Okay, so I'll keep that off to the side here, and let's use a different color here. Okay, so I need the area of the rectangle now. Well, the rectangle is equal to whatever this side is, right? So the full side length is 16 from here to here, right? But we're only concerned with in between here. Well, we know from here to here all the way across was that 4 square root of 3. So I can simply say that this side length right here is going to be equal to 16 minus 4 square root of 3. Okay? And this height is going to be the exact same height of the triangles. So this is going to also be 12. Okay? So this is my rectangle. Okay, so now let's throw that in the calculator. So I'm going to have 16 minus 4 times the square root of 3. That's about 9.07, right? So that is my base. I already forgot the number, 9.07. Okay, so that's the base of the rectangle, and we know the height is 12. So I'm going to multiply that by 12. I'm just going to hit times 12. And I get 108.862, right? If I add that to 48 square root of 3, holy dog crap, we get exactly 192. So if I take the two triangles, this right here, 48 square root of 3 plus 16 minus 4 square root of 3, I arrive at exactly 192. And actually, I'm missing something. That's just the length of the base. What am I? Stupid? Times 12. That will be precisely equal to 192 inches squared. So we get the exact same thing, right? So why have two different formulas? Why not just say the area of any parallelogram is base times height? That's why the formulas match. Okay, so that does it for this video. If you have any questions about anything you saw here, shoot me an email. Otherwise, you know where to find me. Goodbye.